Well, hello everyone. So, I realized I've got this, my kid's easel. It's got a whiteboard piece to it. So, I figured I'd give this a shot. Hopefully you'll let me know how you like it. Anywho, what we're doing today is going to be making a video on series circuits. Okay, what does it mean for a series circuit? What does that mean? Well, here's our source. We always need a source. It's falling. It means that all of our resistors are in a line so that any current flowing through the circuit has just one path. Just one path. That's it, right? It's a nice loop. It can look like this. It can look like this. Right? As long as you can connect it in one big loop, you're good to go. Okay? So, how does putting resistors into a series circuit change the circuit? How does it change the values that we deal with? Well, in order to do that, what we've got to do is look at how the current, the electric potential difference, and then the resistance will change overall when dealing with a series circuit. So let's call this resistor R1, this one R2, and this one R3. Okay? Now, current. Okay? Since the current only has one path, the current through each resistor must remain the same because it's got nowhere else to go, right? Current's coming out of the battery, it's coming here, it's being pushed along, it's all going to go through R1, it's all going to go through R2, and it's all going to go through R3, right? So the current in the circuit, the total current, is equal to the current through resistor 1, equal to the current through resistor 2, equal to the current in resistor 3, and so on and so forth, depending on how many resistors you've got. So that one is nice and easy. So I'm going to erase this whole thing a little bit because I want to write a definition, but I'm going to keep that up here, right? I total equals I1 equals I2 equals I3 equals dot, dot, dot. Okay? I'm going to make a little line because down below is going to be some notes on electric potential. How's that work? Well, in order to understand that, we need to know Kirchhoff's loop rule. Okay? Kirchhoff's loop rule states that the electric potential difference, I'll just write electric potential just for time and space, electric potential drops across each resistor and comes and drops to 0 after the last resistor. Okay, to kind of expand on that, what we're saying is in a closed loop, the electric potential, the voltage, will drop across each resistor until such that the last resistor drops the voltage down to 0 before it gets back to the battery, in which case it gets replenished and keeps on going. Okay, so that is your change for electric potential difference. So let's take a look at what that might look like in a schematic diagram, and we'll then see how that looks something like this. Okay, so here's my schematic, here's my circuit again. This is R1, R2, and R3. Okay, so let's say this is a 9-volt battery. That looks more like a beat. What happens is the current comes along, current passes through R1, some of that voltage drops. Goes through R2, whatever's left, some more of it drops. Goes through R3, the rest of it drops. Now, they don't have to be equal. This doesn't have to be 3, 3, and 3. It could be 3, 4, and 2. Right? It doesn't matter. Right? You don't have to be equal. It doesn't have to do that. It depends on what the value of these resistors are, which we'll do a practice problem in another video, and what the overall voltage is. Okay, and how many resistors there are changes that as well, and so on and so forth. So when dealing with our voltage, we see that the total voltage, okay, so the voltage from the source equals the sum of the voltage across R1 plus the sum of the voltage across R2 plus V3, plus dot, 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 right? So the voltage across this one, this one, this one, all added up will equal the voltage of the source. All right, so let's add that to our line up here. So we say V total equals V1 plus V2 plus V3 plus dot, dot, dot. Again, depends on how many resistors you've got in your circuit. Okay? Now, we can use Ohm's law to help us figure out how the resistance of a series circuit might be affected. Right? So, we know that according to Ohm's law, V equals IR. So what I'm going to do is I'm going to take my IR and plug it into every single V that I see right here. So just to save space, I'll erase that part. So we'll say I total, R total equals I1 R1 plus I2 R2 plus I3 R3. Okay. Now, if you take a look, we see that all of our currents are the same. So if we divided by our current, we would see, doop, 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 doop. We're left with R total equals R1 plus R2 plus R3, plus dot, dot, dot. There we go. And that is how the resistance in a series circuit is affected. The more resistors you add, the more resistance you get, which you can then see from Ohm's law, R equals V over I. If you have a higher resistance, you'll have a lower current. And we'll explore a practice problem with this in another video, but I just wanted to show you this just as a background. Okay? Well, that's it for this particular video. We got what we needed. Current stays the same, voltage adds up, which means the resistance adds up. So, until next time, I'll see you later.